Okay, good afternoon everybody. Welcome to this special class because we need to close the lectures by 28th. I requested for this class. And as I was promising you before, I want to mention one of the most powerful work which is responsible for the so much development on the earth. In fact, no, many a times almost all the textbooks neglect this one directly, try to introduce very indirectly, perhaps which is not correct at all. You can't believe that industries are very much in need of this fundamental thermodynamics always. Okay, so that's why I'm taking this opportunity to talk about the powerful form of work transfer. This is the work which is done by a flowing fluid. In fact, it looks like this is the one which will satisfy maximum requirements of us. If you don't depend on this one, perhaps the development will be almost meager if not negligible. And you imagine, if you see, look at a natural resources, the wind continuously flowing, and we feel that there is some resource which can do the work. And flowing water, the rivers, waterfalls, all these things are there continuously flowing, and they have some capability to the work. So whatever crosses the boundary, and if all that effect can be transferred or is equivalent to raise of a weight, we should call it as a work transfer. And that's how this particular form of work transfer should be defined fundamentally the way we define the displacement work as a PDV. The way we accepted the mechanical work from the definition, first fundamental definition, we should accept this also. So that is what we discussed a lot moving boundary work. And I request all the teachers to explain this electrical work, very important. There are slides on my website which will explain what is flowing through, what is moving through. And the next important thing is the shaft work. And the base for these two uh, the flowing fluid work. Strictly speaking, if you see the hierarchy, can you give me a pen for a while? So if you see the hierarchy of the modern world, and large portion of the work which we enjoy will start with work done by a flowing fluid, okay, and this flowing fluid will generate what is called a shaft work, and this is the shaft work which will be used by Faraday's laws and generating the electrical work. The entire world is dominated by this sequence. A flowing fluid fundamentally doing a work, wind power, hydropower, steam power, gas power, all these things are flowing fluid. They generate a shaft power. Eventually they convert into electrical work. And if you see explicitly very far and are very internal, you don't see force into displacement here at all. There is no displacement of force explicitly available unless you do lot many constructions. But all these works the entire work can be reduced to, means equated to raise of a weight. So that's how one need to have very fundamental definition of another powerful form of work. Go back to the slides. So let me give you this wonderful example which I realized very late. That's the reason why it is not there in fundamental thermodynamics, I think. Let us say somebody developed a wind turbine, this big wind turbine, the big pole, maybe 3 blades, 4 blades, 5 blades, and this is locked, means not to rotate. If I see from the side view, so there is a windmill which is locked, that's why it cannot move. And if it is placed exposed to the wind, what will happen? All the wind streamlines will flow as it is. Nothing will happen. There is no interaction at all. And the moment I open the lock, then it will start doing something. There is something transferred from the wind to the blades, the blade to the shaft, shaft to the gearbox, gearbox to the generator. What is that transferred? All that which is transferred can be reduced to raise of a weight. Means this is a fundamentally work transfer. Now if I want to know how to design a windmill of 10 kilowatt, 500 kilowatt, 1000 megawatt or 1000 kilojoules, what should I do? I make a windmill and connect it to a raise of weight. If it raises the weight, calculate the force into displacement based on that. Means I have to design, fabricate 1000 turbines before I come up with the capacity. That is ridiculous. So you need to have a fundamental reason why I am getting this raising of a weight. So that's where I'm trying to explain the most powerful one. The moment, in fact, no, this is the one which was realized early 1950s. Before that, the people were all doing an indirect development. So the great scientist called a Bedge, he observed, I'm taking this as an example to formulate that fundamental form of work definition, which occurs because of a flowing fluid. Okay, so now you see this one, this particular person, when there is a wind turbine in between, let us say at this particular position, then he started observing, or maybe intelligent way or analytical way, yeah, experimental, yeah, measurement, whatever it may be. Initially the pressure is atmospheric, whatever is the local pressure. The moment there is a wind turbine start rotating, then slowly the pressure increases and reaches to a value at the upstream of the windmill. And across the windmill, the moment it started doing work, means raising of a weight is done, there is a pressure drop across this. Afterwards, the pressure recovers, pressure becomes uniform. And this particular thing, no, they could see by putting a more probes across this one. If you draw, where is the plane on which this pressure difference is occurring? This is the plane or a zone where there is a rotor. Now you can see the beautifully, the wind which is flowing at a far field, and the moment there is a turbine start rotating and doing a work transfer, like reduce it to raising of weight, that effect is happening. The slowly the stream tubes are bulging. Why they are bulging? Because the velocity is decreasing. What happened to that velocity? That velocity is exchanged to raise the weight. Okay, so in fact, the moment there is a flowing fluid, this flowing fluid, no, if you see a wind turbine working, I don't know where is the force. Where the force is getting displaced. Proving it as a mechanical work or a displacement work is impossible, literally. Only, but thermodynamics says it is work transfer. Why? All this effect can be reduced to raise of a weight. Then how do I define this work to calculate? And I want to know, if I put a 3 blades, what will happen? If I put a 5 blades, what will happen? Unless I know the fundamental reason which is doing this particular work, my design will not become scientific. It will become a hit and trial, and the development cost will be very, very high. Development time will be very, very large. Nobody will depend upon this source. The same with the hydropower also. That's why you see this one, the people started looking at the whole system so completely to define this one. Suppose if there is a windmill and start working, there are three things simultaneously happening. The first one which they see is, okay, there is a pressure field which is set up. And if there is no windmill, or if I lock the windmill, what will happen? Wind turbine, what will happen? Pressure will be uniform within the distance. That is a natural thing. All of us know the Pascal law. At a given altitude, the pressure remains constant. So along a given horizontal direction, pressure will vary. The moment the turbine start working, there is a pressure field set up. You see, the pressure increased upstream and started decreasing, and there is a pressure field which is set up. And the entire flow is occurring and passing through this pressure field. And because of which, what action happened? You see this beauty. Eventually, see, initially the wind has a high velocity. All of you know, by the virtue of velocity, it has a kinetic energy that slowly decreases. What happened to this? This entire thing was exchanged with the windmill, and whatever exchanged, whatever crossed the boundary, no, is equivalent to raising of a weight, which is a work transfer. So this entire effect is a work transfer, and beautifully you can see this particular stream tube. Because the velocity is decreasing, change in density is relatively small. In order to keep the mass constant, a decreasing velocity means area of the stream tube should increase. The people could prove that a moving fluid does a work, and whatever action done by the moving fluid is equivalent to raising of a weight. But how does it occur? Not by displacement of a force, not like a displacement which I explained, no, control mass doing. Here, this entire thing is something very different. And how do I set up this particular one? Give me the whiteboard. So now let me explain this particular one as a fundamental definition. The way, somebody explained the force into displacement, the scalar product of force and displacement is a work transfer, which has the units of energy, joules, etc. The same fundamental way I am trying to have. Let me say I have a windmill. Now I am taking a finite width of this entire system. Okay, or just to explain my point and to show, I'll say that there is a windmill of this big. I want to have some kind of spatial comfort to draw. Now what is happening across this particular one, there is a pressure profile which is set up. The pressure has to set. Whatever suddenly happening, no, that I am showing as a broader. Now means the moment there is a pressure field set up, this particular wind turbine will rotate and there is something which is exchanging. This can be used to raise a weight. Okay, so can I have eraser? I want to erase this. Okay. Okay, sorry for this. Okay, now you can see this particular one. So I'm looking at what is causing the entire phenomena which can be reduced to raising of the weight. Sorry. So this is the raising of weight. What is this effect which can be reduced to weight? The moment the turbine started working, at the upstream there is a high pressure and at a downstream there is a low pressure. And the flow is continuously occurring. Okay. Now what is happening? Unless there is a pressure field, a flowing fluid cannot do a work. And similarly you see the control mass where there is a displacement work. Unless there is a displacement, force is not called to do a work. If I apply a force, if there is no displacement, no work. It is the displacement which is primary action leading to force doing. But here what is happening? There should be a pressure field setup. If the pressure field is uniform, nothing will happen. And that is equivalent to raising of a weight. And similarly you imagine second example, unlike a wind, I'll go to the next example. Let us say there is a big terrain like this, hill terrain. The water is falling with an altitude, okay, and all of you know when it falls through a height h, the potential energy decreases and kinetic energy increases. Here there is a water which is flowing with the high velocity, and inside which if I put a wheel with some kind of blades, okay, so the same thing is going to happen. Across the wheel, if I see what is happening, there is a pressure field set up across this particular one, and this pressure field is going to do the work. So that's how the people wanted to define this particular phenomenon, the P inlet and P exit. Whenever there is a flowing fluid doing, there is a pressure field set up. The moment there is a pressure field set up and there is a continuously the fluid is flowing through, the infinitesimal work delta W has to be defined. Now you see this one, in the case of a displacement work, the primary variable is displacement, maybe change in volume or a displacement, F into dx or a P into dV. Here the primary variable is the dP. And what is flowing through this particular pressure field? Some volume, V. Or if you wish, I can say some mass specific volume into dP. The mass into specific volume is total value. Now, in order to justify this one, whenever the pressure decreases, you are getting a work output. And whenever the pressure increases, you have to supply the work. So that's how the people define a definition called a minus. A flowing fluid will do a work and which cannot be defined as a PDV. It is better defined as a VDP. Unfortunately, the conventional thermodynamics books don't define this one also explicitly. This should be done. Without that, the progress of entire nation or a future, mean entire 20th century, what is the one of the marvelous development? Many inventions based on this flowing work. Now let me compare these two on the same thing. Next whiteboard please. Okay, now I am comparing two things. One is obvious, very clear, that a mechanical work, what I call is a displacement work. Displacement work. Okay, so this is the one. Why I am taking this as a reference? This is the one which is very clear to us. Somehow we got convinced. Force into displacement, and the force into displacement dx. The force can be written as a pressure into area into dx. Area into dx can be written as a p into dv. So that's how this we defined as a infinitesimal small work. Whenever there is a system going from an initial to final state, you integrate along this one. To integrate, you need to know the relation between the P and V. If I know the relation, means the process is quasi-static because I have known every state from the initial to exit. This is the inherent way of explaining. Now, what is something which I can understand, this can do very little in real engineering. The one which is actually doing a massive work in the real engineering is work done by a flowing fluid. I am using flowing fluid work. Whatever other books may call, this is you should understand the phenomena, not the name alone. Now what I am defining, a flowing fluid will do a work what is called a minus VdP. Why? Because unless there is a pressure field set up, there cannot be work transfer. Okay, the work transfer occurs because the pressure field is set up. Now you see two parallel things. A displacement work which is easy to feel, easy to understand as a mechanical work is a PDV. And actually the entire globe is driven by a work called a flowing fluid work. Every resource I have now, I'll try to convert into a flowing fluid. You imagine if there is a geothermal power, the underground, because of the magma, I'm getting a lot of vapor under pressure. And out of the pressure, it try to come out. Suppose if I take a small pipeline, what will happen? All that pressure and temperature will produce a high velocity vapor. If I take that vapor and design a turbine, it will go through the turbine. While flowing, it will do a lot of work. And if I burn the coal, what should I use the burn coal? If I burn a diesel or a petrol or anything in a gas turbine, everywhere the flowing fluid work is the one which dominates the entire thing. Now as I said it, in both the cases, you see the flow is traveling from low pressure to high pressure or a high pressure to low pressure. There is a minus VdP. Okay, there is a pressure field which is set up in the entire culture. In the both the cases, you need to know from initial state to final state what is the relation between the pressure and volume. As I was telling you in the last class, the most general way of establishing a generalized process is the PV to the power of n is equal to constant polytropic process. Now it will satisfy all the things. If the n is equal to 0, what is it? V to the power of 0. It is a constant pressure process. Okay. Suppose if the n is equal to infinity, you think very clearly mathematical gamble. If the n becomes infinity, the p is negligible in front of v to the power of infinity. N is very large. So what does it mean? It is called a constant volume process. Okay, so you can get all possible things between the extreme constant pressure to constant volume. Many other things are possible. Mean whether it is a displacement work done by a fluid or if it is a flowing fluid work, the relation between the PV is same. Suppose if I want, I can integrate from initial state to final state, the integral initial state to final state PDV. Or suppose if it is a flowing fluid, I can also say inlet to exit, because there is an inlet, there is an exit, and minus VdP. Okay, in the both the cases, I can replace here P in terms of V. Here I can replace V in terms of the P. Now you will see the beauty of the flowing fluid. And all the teachers, please integrate this one and show the importance of flowing fluid work. Between the same states, the flowing fluid can do more work than the displacement work. And you can integrate and substitute, compare these two. From the state 1 to state 2, if I depend upon a displacement work somehow, and if I depend on a fluid flow work, which is obvious, which looks very easy. So you imagine, one of the greatest thing is, suppose if I have an incompressible fluid, volume doesn't change, something like a hydropower. Suppose if it is a hydropower, if I depend upon a displacement kind of concept, dV is 0, means that cannot do work. Means all the waterfalls cannot do a work if I depend upon a displacement kind of work. But here you see this one, the volume is constant, but the pressure is changing. So whether it is a constant volume or a variable volume, a flowing fluid can do work. But if it is a hydropower, change in volume is negligible. If it is a steam power, volume changes a lot along with the pressure. You see the beauty of this one. You imagine, if I don't depend upon a flowing fluid work, all the natural resources like a hydropower, what to do? How do I do a displacement work or a mechanical work with these devices? Because their volume cannot change. Whatever I do with the pressure, if the device is only the displacement, nothing will happen. Very important. The way we accepted the definition of mechanical work, force into displacement, by fundamental, one should always absorb. You take more examples for truth. The flowing fluid work is as genuine and fundamental as the displacement work. Strictly speaking, the flowing fluid work is much more valuable than this. The moment I have a flowing fluid work, what I'll get? You see this one. And this will rotate the shaft. Okay? A flowing fluid will work because all the blades are attached to a shaft. A windmill or a water mill or a water turbine, wind turbine, steam turbine, all are attached to a disc. The disc will have a shaft. The moment I have a flowing fluid work, it immediately becomes the next stage of useful work. Go back to the slides. So these I have discussed there. So same example which I was explaining, I am giving here. Now you see, the moment I have a flowing fluid work, I'll get a shaft work. Okay, so energy transmission with a rotating shaft is very common in engineering. You imagine all the work that is transferred from the wind to the blades. What is the best way to convert into electrical work? You should have a generator. That generator should be coupled to the wind turbine or a water turbine. Then automatically there will be electrical work done. That's how whatever force, whatever displacement or whatever flowing fluid work. So this is the one. Why I'm taking this example is, this is the classical example of shaft work proposed by the Thomas Savery, and nobody could understand his genius concept. He was thrown out of the army. And if you see carefully now, because you have learned so much mechanics, now all of us know a force acting through a momentum R and generates a torque. All of you know that. The cross product of force and the radius is called a torque. Now you see this one. What I have the wings on the rotor, like a rotor. There is a torque generated. The moment I have a torque, all of us know. How do I create a torque? So a force which is at some radius will, the cross product of force and the radius will generate a torque. The moment it starts rotating, now I don't need a physical displacement. I need an angular displacement only. So continuously you rotate, you do more and more work. Suppose if it is a displacement work like this, what will happen? A piston is moving down. It cannot travel infinite distance, again come back. Again start from the beginning. Now here you see this one. Continuously work. 24 hours a day, 365 days. It can continuously work. Why? It is only the angular displacement. So the flowing fluid does such a beautiful work which generates a torque. And that torque just rotates because you need only angular displacement. Angular displacement will be continuous, 0 to 360 to 720 to so on, so on. And 100 RPM, 1000 RPM, more the number of revolutions, sorry, 100 revolutions, 1000 revolutions, million revolutions, more the number of revolutions, more will be the work transfer. And more will be the work done by the flowing fluid on the wheels or a shaft, blades or whatever it is in general. Now you can see this one. Because it is continuously working, I can calculate how much angular displacement per unit time, which is called a angular velocity. Angular velocity can be easily related to number of revolutions per minute. Now you see power. So what is the power of these systems? These systems can develop a continuous work. Similarly, I request all the teachers to explain a spring work, very essential for the anything. And similarly, there are more important work transfers in a mechanical engineering, production engineering. You imagine the entire metal forming, metal cutting, grinding, all these are doing a work. The force has to displace. There has to be a force, there has to be a displacement. That's why you need so much energy, so much power to do the manufacturing processes. Very important to explain the role of various kinds of works which will go into this one. Okay, this is called a work done by elastic, plastic, solid bars. I'm skipping, and another important thing in the nature is the what is called work done by a surface tension. In fact, no, without a surface tension, no biological system will work happily. Most of the internal organs, internal processes in a human body or animal body are mostly due to the surface tension. Because I don't have much time to have every work, but you should take these examples. What is the work done by a stretching liquid film? What is called a surface tension work? What is the work done by a stretched rod or a spring elastic work? Similarly, what is the work done by electric conductor moving in a magnetic field? That is also there is a force and displacement indirectly or directly. When you see external, you don't see mechanical work, but all that work is equivalent to raising of a weight. So the dynamics gives us such a powerful vision. The fundamental process may not be force into displacement directly, but all these things are equivalent to displacement of a force. All these are very important work transfer. The entire engineering evolved. The more development in engineering means more kind of work transfers we invented, and hence we are enjoying the life. While everything happened, there is something parallelly or almost same time, many a times happening. Another natural happening which we enjoy is the heat action. So without a heat action, no process will work. In fact, either it is a natural or a artificial system, the heat transfer is very, very important. My reading shows, my experience shows that every member of Earth wants a heat transfer for a refresh. Without this, no, the Earth cannot renew. You imagine, how do you get a fresh water every year? How do you get a fresh wind flowing? If the wind doesn't flow at all the air is stagnant around one, then can you live for a while? Whatever we discharge, whatever oxygen we need, all will be consumed in an environment. It looks like the heat action generates many, many things. In fact, people say that one of the most important phenomena for an energy interaction is the heat action. Okay, so according to a philosopher, the first level of engineering in the nature is heat transfer. Every engineering or everything that occurs on the nature, no, because of this engineering action called a heat action. Let me give you, I'm using more statements. Let me go to the one of the important way to understand. Okay, there are two things. Why things are like this in the nature? Somebody says the orange is double the diameter of a lemon, and both are nearly spherical. Because of the spherical nature, they have a largest volume per unit area, and because of which they get exposed less to the solar energy or sun, and they pack lot of juice inside. You see, orange is double the radius of a lemon, contains 8 times more juice when compared to the lemon. And why they are spherical? They have to be spherical, otherwise they'll have a more surface area and they'll lose lot of juice evaporated because there is a heat transfer. Wonderful way, anything. And anybody who is making an artificial device, if it doesn't respect the heat transfer, his entire device will get burned into carbon. And best examples are your computers. You imagine, you have invented a powerful processor, Pentium 4, 5, 6, 7, whatever it may be. If there is no heat transfer from that properly done, within a half an hour, the entire system will burn. That's how naturally what do? They'll have some kind of control system. Whenever the temperature changes, it will hang. So that it will restart the booting, then you will understand. So very important. Natural systems will have a shape, size, etc. because of heat transfer. All the artificial systems which are doing some kind of energy interactions have to have a good heat transfer, otherwise you will fail. Let me give you one of the two wonderful examples, because you have a separate subject where you thoroughly study the heat transfer. I am only giving a philosophical introduction. I am not going into the definitions because the heat transfer is taught very thoroughly when compared to the work transfer as a separate subject. Okay. So let us say this elephant once, African elephant, thought that why I am so different. Now you see, if I see the classification of elephants, I am taking the funniest example to prove my point. These are the most Indian elephants. On the other hand, if you have a same elephant, if it is Africa, born and brought up in Africa, throughout the time they evolve, both are elephants. Why this elephant is so different from the other? In fact, no, once upon a time there used to be elephants in the cold places, and those are now they are extinct because of reason. Now you see, in the cold places elephant. Now you see this elephant. If I want to describe this elephant, so they are called mammoths. They live in a cold tundra region. Now they are not found. That's what the biologists say. They got extinct because of they could not survive. And people say that why dinosaurs got extinct? No, one reason is they could not evolve for a better heat transfer. Massive body. They eat so much. They digest so much. Whenever there is so much metabolism, huge amount of heat is released. High volume, less surface area means there is a problem of temperature control. Either they have to extend or they have to evolve with the time. So some of them got extinct, some of them smartly evolved with the time. Now that's how the people say that. I was very thrilled to see one biologist writing the reason for geometry of elephant is basically a heat transfer phenomena. It has to evolve the entire thing. Let me go quickly. So now to connect the geometry part which we discussed, okay, work transfer is one natural event, one event we wanted it badly. Naturally it doesn't happen much, but the heat transfer is the one which we wanted also happens naturally. That is the difference between the work transfer and heat transfer. Most of the time, no, work transfer is unnatural, artificially invented, and whereas heat transfer is very natural, everywhere occurs. The first level of engineering in life is the heat transfer. Without a heat transfer properly, even God cannot engineer a species unless he does the perfect optimization with respect to heat transfer in a lighter sense. So in light of above feature, a bigger warm-blooded animal should in principle may be generating huge amount of thermal energy due to the metabolism, and because it has a lot of flesh, lot many cells, lot of food it is taking, all will lead to the more amount of heat generation. This metabolic heat release has to be regulated. If it is excess, only through the heat transfer. Otherwise what will happen? Body temperature increases, all the biological cells will die. All the microbes which are surviving in the body will die. Later all the biological muscles, cells will die, and you will eventually die. And when all those animals which could not evolve with respect to heat transfer, they have to die or they have to extinct. So that's the thing. They try to struggle and eventually extinct. The firstly, in such a situation, having a fur coat of hair structure is the least desired, and hence almost most of the animals are bald. Suppose if you see Indian elephants, they have a here and there hair on the body. Suppose if you see an African elephant, the hair is almost nil. They are totally bald. Why? They are having a hair means you are unnecessarily having a blanket of air packet, that is an insulation which is dangerous. So that's how you need to expose yourself. So now you see the beauty. The hotter the climate in which they live, the balder they are, less in air. Not only that, one of the most distinct feature for heat transfer and geometry. Secondly, elephants have a large ears which are packed with the capillary structure. So whenever body temperature increases, no, they will pump lot of blood into these capillaries because these capillaries can expose themselves to the environment. And the moment they are exposed, there will be a good amount of heat transfer which will occur. So that's how all the African elephants, because they are living in a hot environment and they are eating more also, because the delta T available between the body and the environment is very less. So they have to have a large surface area. Not only that, a very interesting feature of this particular one, whenever there is an excess heat needs to be released, more and more warm blood will flow through the ear capillaries. They are exposed. And suppose if the temperature is so high, still it is not, what will they do? They flap the ears. Why? There will be a forced convection, more and more heat transfer. It's very, very important that whenever there is a change of state, heat work transfer may or may not occur because natural systems do not show that much work transfer except animals, etc., which are moving. All the trees hardly show any work transfer, but either tree, as a plant or an animal or a bacteria, all should have what is called a heat transfer. So that's how the next important example is this. Now you see an exotic artificial device. The people developed a marvelous computing microprocessors, integrated microprocessors, very large integration on a small area, 2 centimeter by 2 centimeter area. They'll do a billions and billions of calculations, operations, circuits, etc. And each circuit, each one will have I square R losses. And so much heat release will make them, so unless they answer the heat transfer, these devices cannot survive. Just as an example, you see, there is a Pentium 4 processor. It is a marvelous research. They have so many circuit etched on a nearly 2.2 centimeter by 2.2 centimeter, I think, approximately. Suppose if I build all the circuit here and if I supply the electricity, it may work for a while, and if I don't care, everything will burn. So that's how to make it working. The way the elephant has developed the ears, etc., you need to develop a special attachment to this thing. On the top of this one, you need to have a device which will expose this one to the environment as much as. Even after that, the way elephant flaps, no, you should need some kind of air suction. Now what is the truth? Your entire computer invention of that processor is one, and optimizing with respect to the practicality. You see, you have to develop a what is called a heat sink. You see the heat sink which is put on the top of the processor has so many projections to increase the surface area. Even then it is not possible. That's how you see, when you put everything together, on the top of it there is a heat sink. On the top of the heat sink there is a fan which will suck the air and flow past this. It is like a elephant flapping. You imagine that everything which survives with energy interaction has to have a heat transfer. So what is the heat transfer in general? This is the one. Whenever thermal energy is related to the temperature of the matter, I explained to you. Higher the temperature means more microscopic energy of the molecules. The random motion contains a lot of thermal energy, which I will explain after first law more thoroughly. So for a given material and mass, higher the temperature means more the thermal energy. So the moment you have a system which has a more thermal energy with respect to the surroundings, means its temperature will be higher than the surroundings. Okay, the heat transfer is a study of exchange of thermal energy through a body or a between the bodies, which occurs whenever there is a temperature difference. Now you imagine, whenever there is a mechanical inequilibrium, there is a work transfer. Whenever there is a thermal inequilibrium, means there is a temperature difference between the system and surrounding, there will be a heat transfer. It looks like the heat transfer is a natural phenomena to survive. And without a heat transfer, perhaps systems cannot survive anything which you name it, whenever there is a energy interaction. So when the system and its surroundings are at different temperatures, thermal energy transfers from the hotter body to colder body. That is the law of nature. Okay. So thermal energy always travels from the hot to cold spontaneously without any help, much help. The spontaneous act is called the heat action and heat transfer. Whenever there is a heat transfer or a heat action, the system will change its state. The same way, whenever there is a system changing its state, there will be a work transfer possibly occurring. It looks like it is almost impossible to have. Even if you say also, no, it's a conceptual. I can say that I have insulated. I have insulated means I have reduced the heat transfer, but the perfect insulation to make it a zero is almost impractical. If I can't say impossible, because always. So that's how the heat transfer between the system and surroundings. Always the heat transfer is typically given as symbol Q. Like work transfer, it also has the units of joules, and that way this is a big news. The rate of heat transfer has a joules, work transfer also has a joules. Suppose if it is a continuously changing with the time, the power is a watt, and similarly you can have a joules per second or a watt in the heat transfer also. This is interesting part of it. For a long time now they got confused. Somebody defined heat transfer is calories, work transfer is joules, and there has to be a multiplier, proportionality. All that this thing was a units problem. Strictly speaking, the units of work transfer and heat transfer are one and the same if you think very carefully. So the heat flux, the people know, the entire, I told you know why the lemon has less juice than the orange. Why? The orange contains a surface area in such a way that the amount of solar heat comes into orange is the bare minimum. Why? It has a less surface area exposed to the same heat flux. So the entire world, because of the solar energy, there is some kind of heat flux distribution naturally occurring. And higher the surface area for a given heat flux, you will pick up more heat. And then accordingly, you have to lose or gain. So that's very important for understanding. Okay. The moment there is a heat flux or a temperature difference, then you can have a heat transfer by conduction, generally also called a diffusion. This is one phenomena. When does this occur is when the system and surrounding both are solids, then there is no other way they can exchange the heat, only by conduction. If the system or a surrounding, any one of them is a fluid, then not only conduction, more can happen. That is what is called a convection. I will not describe more than this because you will have a very important course which you are studying where you do lot many models to design the systems for this. Suppose if you are in a situation where either conduction or convection is not possible, number one, or even if there is a contact, physical contact or not, if the system temperature is much higher than surrounding, and there is a critical number which can be understood through, there will be a radiation. So unlike a work transfer, no, I said it, no, there is a displacement work, there is electrical work, there is a shaft work, there is a flowing fluid work, surface tension work, spring work, etc., elastic work. Similarly, the heat transfer also has three crystal clear differences: a pure conduction, pure convection, pure radiation. But in reality, no, any system and surrounding cannot have only one. It is impossible that a system and surrounding will have only convection, only conduction, only radiation. There could be a combinations of any of the three, which is called a real nature is a conjugate heat transfer. It will have more than one mode of heat transfer on an average happening. So I am concluding, whenever there is a change of state, what are the actions can be possible? One of the most valuable, we are striving, so much research, development, engineering, money making, everything which you call it is work transfer. Okay, so there was a saying, survey done that 70% of the mechanical engineers on this globe indirectly or directly contributing for work transfer creation. Okay, so the next important thing is a heat transfer. I did not say much because heat transfer has to be learned more and more. Even work transfer also you will study separately, IC engines, a turbo machinery, or many jet propulsion. All these are all understanding the work transfer in more detail. Designing a control by the mechanical inequilibrium, we enjoy the and a change of state occurs. Any one of them or a combination of these can occur. So whenever these are occurring, what is the engineering? How to account how much, what is the amount of action happen? Because many a time as an engineer, I need to provide an infrastructure to get a finite amount of or a minimum amount of or a maximum amount of. You imagine if we had not evolved in designing the clothing, perhaps the humans wouldn't have existed for a long. Why? The nature created us to be very weak in all respects. We mean just based on the fur, etc., perhaps not sufficient. So that's how you see we started inventing various kinds of clothing. Now you see this one, summer clothing, winter clothing. And if you see the entire clothing design development, one fundamental objective is better heat transfer between the body and the thing so that you are comfortable. Not only that, if the entire clothing is such that whatever humidity or a sweat which you release, if it doesn't evaporate nicely, what will happen? You get smell or you get diseases. So one of the most important research or a scientific event, along with the fashion of course, in cloth industry or a fabric industry is to see the heat transfer properly happening. In a peak winter, better to have an insert. Then what will happen? All the air is packed, only conduction through the air can occur and conductivity of the air is very low, like a false roofing. Suppose if it is a summer, stupid to go for a insert, open it. The moment I open my shirt, and because of the temperature there will be a natural convection, I'll feel more comfortable. Packing is not advisable. If it is a winter, better to have a tight clothing and packing the entire thing. If it is a summer, you should have a reasonably loose where the air circulation is possible. This is all the research. And the fabric and more pores in summer, the cloth will have a more pores in summer, and in a winter clothing should be almost like a plastic. That's why all of you go for a leather jackets, this, etc. Why? You can't afford to have a heat transfer so much in winter. Very important. So every action is promoted by work, heat and mass. Either engineering or a real life, the rule is rule. Okay. So that's how the people wanted a law. How do I design? Can I say that in summer my clothing should be such that not more than this much heat transfer or a more heat transfer? In winter the kind of clothing should be almost minimize the heat transfer. The minimize the heat transfer means I'll choke it to zero, then also there will be a problem, body temperature will increase. Okay, all these things, why shivering occurs, all these are the thing you need to understand. Now you imagine if I don't know how to cover myself in winter, then what, because I don't know how much heat I lose, I don't know how to size, what will happen? You shiver so much, all your ATP will be consumed to generate a shiver and afterwards you will become weak. If you don't eat, eventually you will die out in winter. And suppose if it is a peak summer, then what will happen? Lot of heat generation is not going, you will sweat, 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 and your entire body water will go and you get a dehydration, and eventually if you don't care, again you will die. So very important to know the quantity of action, either human body or a physical turbine or an engine or anything, everywhere. No, very important to know the quantification of an action. As I said, the engineering means getting a number. If you don't give a number, you know nothing. If you give a number, it means you know little, and more precisely you give the number means more and more. That's how the law of sizing, which is called a first law of thermodynamics in general. And how it evolved, what should be the requirement. So I'll come back to this one, maybe I wrongly ordered, I'll come back to this. So sorry. Now let me come back to the first day lecture. I told you why thermal engineering? To develop a artificial animals. Like a regular animals, these artificial animals should also have a cyclic process. Now let us say I have developed a system which is making a cycle like this. A to B along one path and B to A and coming back. I am taking the simple. Can you give a pen? I just write very little only. Hmm. Okay. Now you see this particular one. Now I am coming A to B via 1 and going back to B to A via 2. Okay. You see A1B, B2A. I am doing a cyclic process. My main aim of this particular device is I want a lot of work transfer. So whenever I get net integral is a positive, then I say I am successful. Okay. There should be some finite value. If the cyclic integral of this particular one is 0, all my effort is useless, isn't it? There are some lazy fellows, eat a lot, do nothing. They are waste, they are burden for the nation. Everybody who is eating should do some contribution to the development of the nation. The same way, if I work hard and develop an emission, an artificial animal, engine turbine, if the net work output is 0, means I have done nothing. Suppose if it is non-zero, then there is something good happening. Now the question is, there is a work, the cyclic integral of this work transfer should be some finite quantity. Then I'll get a next doubt. And all other properties, their change is 0 in a cycle. That is the definition of a property. Now there is a work transfer, net work is non-zero and it has the units of energy joules. Now I get a doubt. Is it possible to develop an engine, a system which will have only work transfer and all other cyclic integrals are 0? Then where is it coming from? Conservation of energy. Whether it is a negative or a positive I am talking about. If it is 0, there is no problem. And you doing anything for a 0 net integral is stupid. It is like a lazy person eating and not doing to the society. As good as that, you will create a lazy artificial animals and you have nothing to do with them. Okay, so the conservation of energy is valid. Okay, now the next, let us say I have developed something like a refrigerator or air conditioner. The main goal of this particular machine is, obviously it is working in a cycle. That is the one more sustainable and that is the one which can work continuously. I will not bring that logic again. Now my objective is, the role of this refrigerator is only take out the heat. I will be very happy when the cyclic integral of heat transfer during the cycle should be negative. Why? Then only there is some heat taken from the ice cream and my ice cream will be very good. Suppose if I have an air conditioner in this room, if the cyclic integral is negative means what? There is a heat which is removed from the room and whatever heat dissipated by this computer, me or you, all will be taken out, we are comfortable. So most of the time I am looking for this to be non-zero, preferably negative. There may be some applications where I look for positive also. Those we will discuss later. Now again the same problem. This is a cycle. No other property, whether it is equal or not equal to energy, can be non-zero. They have to be 0. Now there is a question again. Suppose if I have a cycle which has only heat transfer, but that net heat transfer should not be 0, and having a machine only work transfer and cyclic integral of that heat transfer that work transfer should not be 0. Both are violating one of the fundamental law of nature, the conservation of energy. It looks like you are creating energy or you are destroying the energy, which will violate. Suppose if you want a cyclic device to be developed and your main aim may be work transfer only, or your main aim may be only heat transfer, but according to the first law of thermodynamics, it looks like though your aim of developing a cyclic machine is heat transfer, but you need to pay work transfer. Though your main aim of developing a cyclic machine is a work transfer, but you need to pay in terms of heat transfer, which is logically, you see this one, the laws of nature no, have to be understood logically. If you want to prove, you do an experiment. From a square plus b square is equal to c square cannot prove these laws of nature. One has to develop a lot of training and a lot of wisdom, then you will get to come up with these particular laws. So energy can neither be created nor be destroyed. Any questions? No, no? Okay. So that's why. Now the question is, though my objective is only get a net cyclic integral of work transfer, there has to be heat transfer because these are only the two ones whose cyclic integral need not be 0. They can be 0 also, then it is useless. Whatever you are doing is a nonsense. You are doing so much and nothing is happening is a stupid way of spending your time. So that's how in a cycle, the conservation of energy, that's how no, whenever somebody says what is the first law, they say conservation of energy. That is wrong. The basis for the first law is no doubt conservation of energy. But the first law of thermodynamics is more than the conservation of energy. What is the meaning of this one? You are developing a cyclic device. That particular cyclic device is to do a network transfer or a network transfer. Your aim is something. But if you apply a law, conservation of energy, you are getting a first law of thermodynamics. This particular one is called first law of thermodynamics. Why? This is the one which will help you in quantifying the effect which is crossing the boundaries. That could be a work effect or that could be a heat effect. So finally, let me according to me, the first law should be stated like this, because the whole innovation is to produce a cyclic devices, artificial animals. That's how the entire thing started. Later you can use the same law for a different calculations. I'm not against that one, but fundamentally this is the one. You see, if a control mass undergoes a cyclic process, very important, I'm defining only for a control mass. If the mass enters or leaves, perhaps I can't define. And there is a clue inside this one. If you have a cycle, one control volume inlet is going to the other control volume outlet. Outlet of one is inlet to the other. They are connected. So that's how they are control volumes the moment they are doing a cycle. If a control mass undergoes a cyclic process, the cyclic integral of the heat transfer is proportional to the cyclic integral of work transfer. Okay, but later they found that this proportionality constant is a issue of units and mess up, otherwise it is 1. So if I use more standard units like SI units, then the proportionality is just 1. Okay, and this is called this is a law of nature. Why? This entire law logically constructed based on the conservation of energy, which is a law of nature. Energy can neither be destroyed nor be created, is a law of nature, and can be described only for a control mass to start with. But if you want to apply to control volume, you need to know more mathematics, that's all. And basis is only experimental evidence. If you want to prove, you have to do experiments. That's why you see this particular one. The first law can never be disproved, because you can never disprove and hence it gets proved. Whenever I say that proving of a first law, if you try to violate, perhaps it cannot happen at all. The first law, what is the consequence of engineering? I always say, no, the thermodynamics is a science of innovation. Every innovator should have some kind of control over his innovation. Tomorrow I'll talk about the consequences of first law to an engineering invention. Okay, so thank you.